right, guys, so this activity talks about determining the DR and BDR from scaling networks. So we're basically going to investigate the election of the designated router, and we are going to make changes to it as well. We're going to see who is the designated router, who's the backup designated router. So if you guys don't remember what the designated router and backup designated router roles are, they're basically going to be the only two routers that will form a full adjacency with all the other routers. So when we talked about Ospf, we saw that one huge disadvantage of Ospf is the fact that we need to form adjacencies with all the other routers. And because this may not be feasible sometimes because of the amount of routers we have in the topology, we do have the designated router and backup designated router roles. That basically means that when there are changes, the routers, they don't need to tell all the other routers. They just need to tell the designated router and the backup designated router, and they will be responsible for basically forwarding the changes to all the other routers. So we do have to remember that we have three roles. We have designated router, the backup designated router, and we also have the drawder. The drawder, the D router, is just all the other routers which are not designated routers and not backup designated routers. So let's do this activity because it's going to help us understand a little bit better of how the election process works. Now, if you remember, if you recall what we talked about last week, on the serial connections, they are considered to be point-to-point connections, and by default, they don't require an election. All right. Now, all the gigabit interfaces of the router, they are considered to be a broadcast interface, and because of this, they will have elections by default. So whenever we show the IP or SPF neighbors and we see that there is no information about designated router or backup designated router, that is because that specific interface doesn't have an election process. Okay. Now, for this scenario here, all the interfaces being used in the routers, they are the gigabit interfaces. And because of this, there will be an election process. We have three routers. Who is going to be the designated router? Okay, so let's check it out and see what's going to happen. So the scenario is we're going to examine the DR and BDR roles and watch the role changes when there is a change in the network. We will then modify the priority and to control who is going to be the new designated router and who's going to be the new backup designated router. And we're going to verify the routers are in their desired roles. So let's examine the DR and BDR changing. So step number one, wait until the amber lights turn green. So we already waited enough. Everything's green in the design. Verify the current OSPF neighbor state. Does anyone want to say anything? Nipes, do you say anything?
No.
Okay. I thought I heard something. All right. So verify the current OSPF neighbor state. So use the appropriate command on each router to examine the current state. So let's start with router A, CLI, and we're going to type it in the command necessary to show that. So do you guys remember? So if I issue the command show IP OSPF neighbors, check it out. We will have the information about the state, okay, and the role of the router. This is the role, this is the state. And if you remember, the state is just basically telling us that everything has converged. They have already exchanged the necessary information about the networks. And it's showing us that this interface 3133 is connected to a router which is a designated router. Okay, and the other interface connected to the 3122 is connected to a backup designated router. So if we have a look at the topology, the 33 is actually router C. It's basically telling us that currently router C is the designated router. And router B, which is this, all right, is the backup designated router. And the function of the backup designated router is just to be a backup in case the designated router fails. Okay, the backup designated router will then become the designated router. All right, so what happens? So if these two are the designated routers, what will happen if we type the same command on router B or C? What is it going to tell us that router A is? Let's check it out. So show IP OSPF neighbors. So you remember I told you that every router which is not a backup designated router will be a drawder. There you go. It's saying that router A is a drawder. Okay. So that's all we need to check the roles. Let's see what else we need to do. Turn on IP OSPF adjacency debugging. Now the debugging messages, they help us identify if there is something wrong with OSPF. So if we go into router A and we type debug IP OSPF adjacency, every adjacency information will create a message to us. So let's enable debugging with debug IP OSPF adjacency. Now, when we use a debug command, it helps us troubleshoot issues with protocols. And here we are trying to identify issues with the adjacency. So we do have OSPF adjacency events debugging on. We're going to do the same for router A. Debug IP OSPF adjacency. Now disable the interface Gigabit 00 on router C. So let's go into router C and disable. Wait 30 seconds for the dead interval of router A and B. So after we turn it off, after a while, router A and router B will not be able to communicate with router C anymore. So this timer is the dead timer. So after the dead timer expires, which is 30 seconds by default, about 30 seconds, we will see that the adjacency with router C will be lost. Let's do that and see what happens. Router C. Oops. Router C CLI. Interface gig 00. We're going to shut it down administratively. Okay. And we'll see what happens with router A and B. Takes a while until it expires. I'm going to speed up things here. And there you go. We got the debug messages. So with the debug messages, we can actually see exactly what happened. So right here, we lost connectivity with router C. Then we see that a whole bunch of events happened. So they try to re-elect the designated router and backup designated router because the access, the connection to router C, which was a backup designated router, was lost. So they basically need to do the election again to elect which one is going to be the new backup designated router and so on. This is basically everything that's happening here. Now, in the end, this router was elected the backup and router B was still the designated router. All right, cool. So let's see what else. Restore the gigabit interface on router C and re-enable the link. Wait for the elections to happen again. And then we're going to see the rows again. So go to router C again. No shut on the same interface. Let's use the fast forwarding time. Let's see what happened. As we can clearly see from the debug messages, a new election happened again. Okay, let's see the rows now. So let's go to router A, CLI, and let's do a show IP OSPF neighbors. And now we'll be able to see that router A is connected to a DR, which was still router B, and a drawder, which is now router C. So before, router C was the backup designated router, and then it went down. When it went down, it had to elect a new backup designated router. So router A was elected the new backup designated router. And even though we brought router C back to life, it was a new election doesn't need to occur because now we do have designated router and backup designated router already. So we don't need to trigger an election again. So the thing that was there before, the fact that router B was the designated and router A was the backup designated, will not force an election again. And router C will just become a drawder now. So that's it. So let's see what else we have to do. Disable the gigabit interface on router B. So if we do that, what's going to happen is we are going to cut connectivity to router B, which is the designated router. And that's going to trigger a new election. And when we do that, router A and router B will start the election process again to decide who is going to be the designated router. Let's do that and see what happens. So let's go to router B. Interface gig 00. Oops. Configuration mode. We're going to shut down the interface. Okay. Now, when we shut down the interface after a while again, a new election will happen. And what's going to happen with the rows? We are going to elect a new router as the designated router. And who is it going to be? It's going to be router A. Now we're going to discuss why in a few minutes. After that, we're going to re-enable the link again. Interface gig 00. Oops. And we're going to do a no shut. And that's all. Let's fast forward in time again and see what happened with the rows. Router A. Do show IP OSPF neighbors. Oops. Still not back. So I'm going to go router B. No shut. Fast forward in time. Router A. Do show IP OSPF neighbors. And now we'll be able to see that router A is the designated router now. Router B is being elected the drawder. So it's just a drawder. It hasn't been elected in anything. And router C is now the backup designated router. Cool. All right, done. So what is going to play a role in the election process? So you see that there is a priority number here. We do have a priority number on this adjacency and one on here. So if you remember, the highest priority wins. So if this is 1 and it's just a drawder, this is 2, it's a backup designated. What's the priority on the designated router? Let's move on to a different router and check it out. I'm going to go to router C. Show IP OSPF neighbors. Check it out. So designated router is this, which is router A. Okay. Now that still doesn't quietly explain why it has been elected the designated router. Okay. So let's have a look at what else we have to do to identify that. So to change the DR and BDR, we're going to configure the gigabit port on each router with different priorities. Now, let's go ahead and do just that. Okay. So we're going to go to router A and we're going to change the priority to 200. So let's go ahead and go to router A, CLI, interface gigabit 00. Now to change the priority, we just need to specify we want to change OSPF priority. So the command for that is IP OSPF. Yeah. And then we specify the priority. Now the IP OSPF priority we want to configure on router A is 200. I'm going to type it in 200. You remember that the priority goes from 0 all the way to 255. So for this one, it's going to be 200. For router B, it's going to be just 100. So let's go to router B. Interface gig 00. IP OSPF priority 100. And router C. Interface gig 00. IP OSPF priority 1. All right. So now what we expect to see is that the router with the highest priority will always be elected the designated router, followed by the second highest, which is going to be the backup designated router, and all the other routers will be drodders. So let's check it out. Now, the fact that I have changed the priority will not force an election. There are two ways we can force an election. One way is by saving the config and then power cycling all the devices, so turning them off and on again or reloading them. And the other alternative is by clearing the OSPF process with the command clear IP OSPF process. So we're going to do just that. So I'm going to go back. We're going to type it in clear IP OSPF process to get rid of everything that we configured before. Oops. One mode back. And we're going to say, yes, we want to reset everything on OSPF. And we're going to do this for all the routers. Okay, so we're going to go router B. Do clear IP OSPF process. Yes. Same thing for router A. Say yes. And now we're going to be able to see what has happened. So let's go to router A and type it in. Do show IP OSPF neighbors. And now we're going to be able to see that the priorities that we configured, they have been changed. All right. So this is now 100 for router C. Router A is 200. So that basically means based on the priority, router A will be elected the designated router and router B will be elected the backup designated router. All right. Cool. So we are pretty much done with this activity as well. That's all we had to do for this one.